You're in charge. So we got water. Here's water, H2O. Now, water does something special, party people. Water self-ionizes. Now, it's in equilibrium with itself. So water liquid, by itself, breaks apart into an H plus and something called a hydroxide. Now, I'll stop here. They call this a hydroxide. And by the way, we've dealt with this hydroxide. This hydroxide is listed in table E. This is called a proton. It's listed in table O. Okay? Just to show you what I'm talking about, if I go to my reference tables, let's see where they are. Maybe they're over here. Okay, let's go to table, make this smaller. Okay, let's go to table, what the heck is that? Table E. And we can see very clearly, the ring is gone. Now, actually, it's still here. But OH minus is our hydroxide. Now, you may say, where is the H plus? Now, H plus, party people, is also listed in the table that we talked about earlier, in table O. Oh, no, he didn't. Okay, plus, here we go. So there we go, proton. A proton is an H over 1. Now, what a proton is, my friends in chemistry, is a hydrogen nucleus without an electron. So when you say H plus, H has 1 proton, 1 electron, no neutrons. So when it loses its only electron, it becomes just a proton. If you remember from last year, oh, it was last year we did this. If I write H 1 over 1, this is the proton number. Hey, some review, stuff that we have to know. This is 1 proton. And when I say atom, you say neutral, atom, neutral. Atom. Neutral. Right, now if it's neutral, that means the number of protons, which are positive, equal the number of what? Electrons, which are negative. So this is 1 proton, 1 electron. This is the mass number. Who has mass? Protons and neutrons. So if I've got 1 proton and I subtract 1 minus 1, I get 0 neutrons. So if I draw a very simple diagram, here's a positive nucleus, here's an electron, this is my proton. Lose my electron, what am I left with? I have 1 proton, I have an electron, I have 0 neutrons. If I lose my electron to become H plus, what am I? Just a proton. So if you hear the word proton or H plus, they are synonymous. Proton equals H plus. If you forget, it's there for your viewing displeasure table. Oh! All right, so let's continue. All right, back to where we were. Let's make that small, minimize that. All right, so we've got a proton and a hydroxide. Now, there's another way to write this, party people. I can write it this way. Some people consider that this auto-ionization reaction happens this way. We can't watch them occur, but it certainly can. So you have 2 water molecules. This is important. They come together. And now, what happens? Well, 1H from the water, or 1 water donates something called a proton. And the one who accepts the proton becomes H3O plus. H3O plus is called a hydronium ion. Hydronium. And it's a polyatomic ion. The reason it becomes positive 1 is because it gained a proton. This entire molecule gained 1 proton. So the whole thing becomes charged. If you don't know what a hydronium ion is, you go to table, what the heck is that, on table E, and we'll see that the hydronium ion is listed. Notice it sounds a lot similar, or very similar, I should say, to OH minus. So there is the hydronium ion in all of its glory. Not the H2 plus, but you get the point. Okay, so there you go, H3O plus, and then we have the hydroxide. All right, and those two guys will be used a lot. They sound very similar. If you get this wrong because you thought hydroxide was hydronium, you're just being lazy. Okay? It's right there for your viewing displeasure. So let's minus that away and back to what we're talking about. Now, if H2O gives off an H, if water gives off an H, well, one becomes H3O plus, the other one becomes the hydroxide again. All right? This happens in water all the time. It's an equilibrium. Now, this is very important to keep track of in my water because life processes occur in a very narrow region in terms of how much of this or this can occur. Now, I'm using these synonymously because these two right here can be used interchangeably. So when you think of a proton, whether it's an H plus that came off the water, or you think of a hydronium ion, these are synonymous. These are used interchangeably. Okay, now let's put this together a little bit. We know that this happens in equilibrium, and we know exactly how much exists. In fact, we have something called an equilibrium constant. It's called KQ, in this case KW. And it tells me something about how much of my products compared to my reactants exist at equilibrium. In my last week in my gas tank lab, I think Kara had the higher tank or I had the higher tank. This K would tell me who's favored, reactants or products. At equilibrium, as we learned, never is the products equal to the reactants. So, KW for water, for this reaction, is going to be equal, okay, believe it or not, to the H3O plus or the H plus. They're synonymous. They're measured the same. Whether you have one or the other, it means the same, times OH minus. Now this is a very, very important equality. There's a constant at a certain temperature that never changes that gives me some number of these two values. Never changes. Meaning, as this one goes up, if this is going to stay constant, what does this do? If this is equal to 10, right, and I have two numbers that equal 10, okay, when they multiply together, because there's no addition, as one goes up, the other one has to go what? Down. It's an inverse relationship. We learned that already. Hey, some more review. Gas laws. Pressure times volume equals a constant. Now, because that number, this KW, does not change, and it's linked to a temperature, then we can look at these ratios a little differently. And let me explain. Okay? This number for KW actually equals 1 times 10 to the negative 14. Let's put it there. It's a small number. 1 times 10 to the negative 14. What does this mean? This means that water barely becomes this. If that's KW is really equal to the what? The product of my ions or my reactants. KW equals how much reactants I have. This times this. Brackets represent molarity. If it's a small number, it means that we barely make any of this, which means that the reactants are favored equilibrium. This is the tank with all the water in it, and this is the tank with a little bit of water in it, even though they're at equilibrium. Water is a terrible electrolyte. What does that mean? Doesn't conduct electricity because it doesn't make a lot of what? On its own. Doesn't make a lot of what? Free ions. It barely does. This is the product of these two numbers. This times this equals that. That's a tiny number. It barely does that. So even though it's at equilibrium, it barely makes these ions. Water does not conduct electricity on its own. It doesn't make enough ions. But we still need to know how much of these are in my water because life depends upon it. Organic chemistry depends upon reactions working with this amount of presence or this certain amount of water, certain amount of protons and hydroxides in water. The balance right here, okay, is very important in many reactions. Organic chemistry represents about 98% of all reactions. Life-sustaining reactions depend upon this balance. So we want to take particular care of what this is. Okay, now, if these two numbers are the same, watch. If these two numbers have to be the same, now think with me for a second. Every one water breaks apart into one of these and one of these. every 2 of these breaks apart into 1 of these. Bottom line, what's the ratio? It's a 1 to 1, correct. So if I have nothing else in water, doesn't it make sense that these guys will be the same, whether you think of it as a hydronium ion or a proton? Won't these be the same if I got pure water? Absolutely. 1 water breaks apart into 1 of these. So if I have nothing else in water, these will be the same. I know this number to be true. So what number times itself equals this? If you haven't done any exponents in your math class, I'll help you. They have to be 1 to 1 because every 1 water breaks apart into 1 proton and 1 hydroxide. So what number that's equal to each other times itself equals to 1 times 10 negative 14? Anyone? 1 times 10 to the... When you multiply numbers that have exponents, what are you doing with the exponents? You add them. So this would be 1 times 10 to the negative 7. And 1 times 10 to the negative 7. Now, for those that don't know what I just did, 1 times 10 to the negative 7 is 0.0000. 1, 2, 3, 4, 5, 6. Right, that's a tiny number. Why? Because water barely breaks apart into ions by itself. But that's a concentration, and this one's the same number. Okay, big deal, Mr. Grotsky. So what? Well, my friends in chemistry, water is usually never pure, and there's usually something happening in water, aqueous solutions. Now, don't forget what this represents, the H3O plus, H plus concentration. Now, stay with me right now. This is one of the most important factors in organic chemistry, living, sustaining reactions, is knowing the balance of these two. Now, because I want to pay particular care of what this value is, or this value, I use something called pH. You've heard of pH. You all have heard of pH. You probably don't know what it is. Okay, here's what pH is. pH means the negative log. Now, what is a log? Well, a log is a way of taking this entire number and stuffing it into an exponent. It's a way of taking this I'll say hugely small number, which makes no sense, but this very small number, it takes a lot of space, and stuff it into an exponent, base 10 exponent. So 1 times 10 to the, if I just did the log in my calculator of 1 times 10 negative 7, I would get 7. That's the exponent. But since I do negative log, I want you to take the log of this, which is negative 7, and times it by negative 1. And what do you get? What do you get? You get 7. The negative log just means take the exponent and times it by negative 1. Take the positive value of the exponent. And I get a pH of 7. Do not pick this one, although it'd be the same number in this case. Anyone know what this would be if I did negative log of this? It'd be, P means negative log. It'd be the POH. We don't want the POH, I want the pH. But this is the POH. So negative log of this number would also give me 7 in this case. Now, we do not normally talk about the POH. But what do you have to know? The pH is about the H's, the H pluses. I don't want the POHs. Let's stay with this now. Anyone know what's special about a pH of 7? It's neutral. Why is it neutral? It's not acidic or basic at a pH of 7. And you know why? It's right there in front of you. The H pluses, which come from acids, equal the OHs that come from base. These values are equal at neutral pH. You don't have something that's more positive, more acidic or basic. So my friends in chemistry, if you didn't already know, this is the acidic area. Acids mess around with this number. Bases mess around with the hydroxide number. So bases will affect this concentration, acids will affect this concentration. If you've got pure water and no acid and bases are added, these will be equal, and the pH is 7, and it's neutral. And we write that the H pluses or the H3O pluses are equal to each other. So the H plus or the H3O plus, I'll do this better. So we'll say neutral, pH of 7. It's very important, neutral pH, as you guys knew. But what does it mean? It means the H pluses or the H3O pluses, they're synonymous, equal the hydroxides. And that only occurs in pure water, nothing else added to it. Okay, let's change the game. Okay? So let's change the game. Okay, let's get rid of this right here in the bottom. Okay? And just focus, guys, because I'm telling you, if you take any breaks right now, you're not going to want to do. Now watch. I'm going to change this concentration. I'm going to pretend that the acidic level went up 1,000 times. Someone added acid to my water and it went up 1,000 times. What's 1,000 times bigger number? 1 times 10 negative 7. Remember, 1,000 is 3 zeros. So this would be 1 times 10 to the negative anyone? Right. 1 times 10 to the negative 4 is 1,000 times bigger. Now people are saying, how in the world do you do that? Well, because this is 0.00000001. That's this guy. This guy is 0.0001. Can you see they differ by 3 zeros? This one's getting closer to becoming 1. It's bigger by 3. 7 minus 4 is 3 zeros. Each 0 on base 10 logs is a 10. So this is bigger by 1,000 times. Now what did I teach you, party people? I taught you that the KW doesn't change. So that means that this times the hydroxide still must be 1 times 10 to the negative 14. So what must this be? 4 plus what is 14? I say plus because we're adding exponents, we multiply. 4 plus what is 14? Negative 10, right. How did I do that? I'm going too fast. You know what I just did? This number can't change. It's a constant. This went up 1,000 times. This must drop 3 zeros 1,000 times. These two numbers, exponents, when added together, must equal 14. Now watch. We just added an acid. What's my pH now? pH is about what? The H plus ion concentration. What's my pH? Negative. Take the positive value of the negative x. Yeah, the pH is 4. Notice I'm using what? This concentration. I don't pick this one. This would be the POH. You don't use that. You use the H plus. Now, what is it true? When the pH gets 4, I'm below 7. If the pH is 4 and I'm below 7, as you guys have just said, it's the acidic range. What does that mean? Who's in greater quantities? Which number is bigger? I know it's weird thinking with negative exponents. What number is bigger? This is 0.0001. This is 0.0000000001. Who's bigger? This one. So there's a heck of a lot more H pluses. So in the acidic range, you've got H pluses and or H3O pluses, they're synonymous, that are bigger than the hydroxide concentration. And this is important, people, because there's only a slight range where life can exist in pH. So you would say, well, pH 4 doesn't sound like a lot of acidity. It's 1,000 times bigger. What if the pH was 3? How would the pH change from 4 to 3 in terms of exact amount? If it's 1,000 times different from a pH of 7 to 4, what would be the amount difference in acidity from 4 to 3? 10. Each single integer is an exponent. You have to know that. I could ask you on a Regents. compare a pH of 7 to a 4 in terms of how much more acidity. You would say it's acidic by 1,000 more times. That's even though a pH of 4 and 7 looks like three numbers, each one of these is an exponent base 10. Okay? Let's add a base to the problem. Now if I add a base, what number is going to be higher now? Yeah, let's increase this OH to 1 times 10 to a negative 3.
But you would still look at the first column.
Absolutely correct, because we're looking for a pH. Correct. Good job. Even though I'm changing this number, I'm looking at what this becomes, and that's another Regents problem. What if the hydroxide concentration is 1 times 10 to the negative 3? What's the concentration of my H plus or H3O plus? 1 times 10 to the negative 11, because 11 plus 13 is 14. What's my pH? What's the positive value of my negative exponent of this guy?
11.
Yes, my pH is 11, and you guys learned when the pH is greater than 7, okay, in this case the pH of 11, who's bigger? What number is bigger? This is bigger than this one. There's more hydroxides in my solution. So you'd say hydroxides are greater than the H pluses or the H3O pluses. So what did we learn here today? pH of 7 is neutral because you have to have equal amounts of these guys. If you increase one by adding an acid, as acids affect this one has to get bigger, it's not there though, and the other one gets smaller, and we always evaluate. What if I did this to you? If the pH is 4, what's the H plus or H3O plus concentration? If the pH is 4? 1 times 10 to the negative 4. What's the H plus ion concentration if the pH is 11? 1 times 10 to the negative?
11.
Right. What if I said to you, the pH is 5. What's the hydroxide concentration? Tricky. If the pH is 5, what's the hydroxide concentration? Correct. What's the pH? If the pH is 5, what's the H plus ion concentration? 1 times 10 to the what?
Oh, still looking at negative 9.
Yeah, 1 times 10 to the negative 5 is the H pluses, but what must be the hydroxides if this has to equal to 1 times 10 to the negative 14? Negative 9. Cool.
Is it always going to be negative 14?
Yes, that's a constant.
Will we have a question like that?
Yes. Let me show you. Let's go there. Okay, let's go there. How about the question I just gave you? It's almost like I planned it. Okay? Let's look at this, party people. Number 1, let's be crazy and start in order. What is the pH of a solution whose H plus ion concentration is 0.0001?
We don't have that.
Yeah. Why don't we just look?
Okay, just look up here. I thought I gave that out to you. Just look up here then. I thought I gave it to you. Okay, what is 0.0001? 1 times 10 to the negative 1, 2, 3, 4, right? So they're really giving you that. So if the H plus ion concentration is 1 times 10 to the negative 4, what's the pH? Oh my gosh. Okay, I'm sorry, I'll have to